Hello, and welcome to the Electrolyte Club. My name is Helbert Rondon, and I am a nephrologist at the University of Pittsburgh. This is lecture number 3, Pathophysiology and Etiology of Hypotonic Hyponatremia, Part 1. The learning objectives for this lecture are: number 1, to describe 4 pathophysiological scenarios causing hypotonic hyponatremia. Number 2, to explain the underlying mechanism shared by all hypotonic hyponatremias. Number 3, to list 2 basic mechanisms causing free water excess. Number 4, to explain the pathophysiology of hypotonic hyponatremia due to increased water intake. And number 5, to describe the key clinical features of hypotonic hyponatremia due to increased water intake. In lecture number 2, we review the Edelman equation, which is the master Dysnatremia equation. And this equation states that the plasma sodium concentration is equal to total body sodium plus total body potassium divided by total body water. For didactic purposes, we're going to forget about total body potassium, and we're going to say that the plasma sodium concentration is the ratio between total body sodium and total body water. Based on that equation, we can infer that there are 4 scenarios that can cause hyponatremia. Scenario number 1 is when the total body sodium is normal and total body water is greater than normal. And typical examples of these are psychogenic polydipsia, but also low solute intake and low GFR as well. Scenario number 2 is when the total body sodium is low and the total body water is also low, but total body water is a little bit higher than the total body sodium. And the typical example for this is hypovolemia. Scenario number 3 is when the total body sodium is high and the total body water is high and higher than total body sodium. And the typical example for this is heart failure and cirrhosis. And finally, scenario number 4 is when your total body sodium is low and the total body water is high. And the typical example for this is patients with SIDH and cortisol deficiency. If you look at the 4 scenarios, you notice that in all of them, water is greater than sodium. If we look at scenario number 1, that portion of water in blue there, if I get rid of that, the hyponatremia disappears. In scenario number 2, that portion of water there, if I get rid of that, the hyponatremia disappears. In scenario number 3, that portion of water in blue, if I get rid of that, the hyponatremia disappears. And finally, scenario number 4, that portion of water there, if I get rid of that, the hyponatremia disappears. So all hyponatremias have this common blue area that is basically free water excess. So all hypotonic hyponatremias are characterized by having a free water excess, which means that total body water is greater than total body sodium. So hypotonic hyponatremia is always due to free water excess. And why do we develop free water excess? There are only 2 possible causes. Number 1 is because we are drinking too much water, increased free water intake, or we're drinking a normal amount of water, but the kidneys cannot get rid of that water, decreased free water excretion. So let's look at increased free water intake hyponatremias, and we'll talk about a case scenario here. This is a 25-year-old woman with a past medical history of schizophrenia who is referred to you for polyuria, 4.5 liters per day of urine output. She takes risperidone as her only medications. On exam, her blood pressure is 115/65, heart rate is 67, there is no jugular venous distension, the lungs are clear to auscultation, there is no peripheral edema, and the patient psychiatric exam shows delusions of cleansing her soul. The labs show a sodium of 131 and a urine osmolality of 57. So the question is, what is the most likely cause of hyponatremia in this patient? Letter A, SIADH. Letter B, primary polydipsia. Letter C, low solute intake. Or letter D, decreased effective arterial blood volume. And the right answer is letter B, primary polydipsia. Now, how much water does someone need to drink to develop hyponatremia? Is it A, more than 5 liters in 24 hours, B, more than 10 liters in 24 hours, C, more than 14 liters in 24 hours, or letter D, more than 18 liters in 24 hours? And the right answer is D, more than 18 liters in 24 hours. So the kidneys can handle a lot of water. You know, if you drink water, the kidneys are able to excrete most of the water that you drink, but there is a limit, what we call a maximal renal water excretory capacity. And what is that limit? So we can calculate that. So we all know urine osmolarity, which can be conceptualized as the number of osmoles or solutes in the urine, called the urine solute load, divided by the urine volume in 24 hours. If I move the terms of the equation and move urine volume into the left and urine osmolality in the denominator, then we'll have this new equation that states that the urine volume is equal to the urine solute load divided by the urine osmolality. Now, in order for the urine volume that the kidneys can excrete to be the maximum possible, then the numerator, urine solute load, has to be the highest possible, and the denominator, the urine osmolarity, has to be the lowest possible, right? So, what is the highest urine solute the kidneys can excrete? Well, again, when you're in solute balance, the amount of solutes that you eat is the same amount of the solutes that you excrete. So if you're eating a certain amount, you have to excrete that amount in the urine. So the normal amount of solute intake is 600 to 900. So 900 would be the highest solute load you can eat, and therefore the highest solute load the kidneys can excrete. So therefore urine solute load is 900 milliosmoles per day. What about urine osmolality? So the urine osmolality ranges between 50 to 1200. So 50 is the lowest urine osmolality the kidneys can generate, 1200 is the highest. So in this case, it will be the lowest possible, which will be 50, and that give you 900 divided by 50, a urine volume of 18 liters per day. So the kidneys can excrete up to 18 liters per day. So if you drink more than 18 liters per day, the kidneys cannot excrete the extra, and you will retain it, and it will cause hyponatremia. Now, this is the same as saying that the kidneys can excrete 750 mLs an hour. All right. So if you exceed that capacity of excretion, 750 mLs, then you can also get into trouble. So what happens in hyponatremia from increased water intake? You have the total body sodium and total body water, those boxes there, and they are at the same height, representing that there is a normal ratio between total body sodium and total body water. So all of a sudden, then you're going to start drinking a large amount of water, or drinking it too fast, exceeding the maximal renal excretory capacity, and therefore the kidneys won't be able to excrete much more than they can handle, and there will be an increase in the total body water that will be now higher than total body sodium, causing hyponatremia. Now, what are the main causes of hypotonic hyponatremia from increased free water intake? Primary polydipsia, as I explained, is one of the main causes. It usually happens in patients with psychiatric problems, schizophrenia, where they have delusions that they have to drink water somehow, or they're taking medications that cause thirst or dry mouth, and they feel the need to be drinking water all the time. We also have now water drinking contests. You know, in the past we have beer contests, especially in like fraternity pledges. Now, because they think beer is bad for you, then they have to switch to water, and they don't realize that water can be a poison as well if you drink a lot of it. So there have been deaths in college students who are pledging for fraternities because of this. There has been also water drinking competitions in the ratio where people have also died from drinking too much water. So those are the things that you might face when you see patients with hyponatremia from increased free water intake. Now there are other two conditions, and these are exercise-induced hyponatremia, also known as marathon runner's hyponatremia, and MDMA or ecstasy-induced hyponatremia, where increased water intake is a large part of the reason why these patients develop hyponatremia, but also other situations such as increased ADH can also contribute to the hyponatremia in these conditions. For instance, exercise-induced hyponatremia or marathon runner's hyponatremia, this happens. It was described for the first time in the Boston Marathon in 2002. It's reported in the New England Journal of Medicine, where runners were, especially women, they running the marathon and they were finishing the marathon and having seizures, and when they checked their sodiums, they were pretty low. And what happened is that these women were stopping during the race and drinking water or Gatorade, which is hypotonic, and they gained 4 or 5 kilograms of fluid weight very quickly in the 3 or 4 hours that the marathon lasts, causing significant hyponatremia. Also, people who use ecstasy, especially in the context of rave parties, where they dance all night, they feel thirsty because they're using ecstasy, they drink lots of water, and in the morning they develop severe hyponatremia, usually associated with seizures and coma, or at least mental status changes. So these are the conditions where you could see hyponatremia from too much water intake. Now, what are the clinical features of hyponatremia from increased water intake? You have a low urine osmolarity because the hypotonicity or the low osmolarity is causing suppression of ADH. So since there is no ADH, the urine osmolarity is going to be low, less than 100. And these patients are clinically euvolemic because they haven't lost or gained any total body sodium. So hypotonic hyponatremia again is due to free water excess, which could be due to too much water intake or normal water intake with decreased excretory capacity by the kidneys. Too much water intake can be due to primary polydipsia, drinking contests, but also exercise and ecstasy, and again with the caveat that in these two conditions, exercise hyponatremia and ecstasy-induced hyponatremia, there is other mechanisms causing the hyponatremia, such as increased ADH. So the take-home points are: hypotonic hyponatremia is always due to free water excess. Free water excess develops because of either increased free water intake or decreased free water excretion. Hypotonic hyponatremia due to increased free water intake occurs when water ingestion exceeds the renal maximal water excretory capacity. Hypotonic hyponatremia due to increased water intake is characterized by euvolemia and low urine osmolality. Thank you for your attention.